This video is a rundown on how to get this mic jack powered 555 oscillator up and running and working to create a CW keyer in software. Right now we're just going to do a overview, and then I'll come back and get into the details. So it's already up and working. So basically what we're doing is taking this 2 kilohertz oscillator, TLC 555, sending the output into the left and right stereo microphone jacks, so the laptop, and creating a regenerated CW note using a couple of apps, Trigger MIDI Mono, the DITs, and the DAWs. And the blue wave is the actual 555 voltage coming in. And as long as that voltage is down, is above a threshold, it sends DITs with the AD5DZ CW keyer app, which I'll cover again in the details. Here's the DAW side. So this Trigger MIDI Mono takes the average voltage of the 555, and when it goes above this pink wave, which I'll show you here, kind of a purple pink wave, then it triggers the internal engine to start operating. So it converts those DITs into a green wave. So the blue 55 voltage is converted to a green MIDI data information that perfectly clones the blue wave. So that green wave, which is MIDI data, comes out of Trigger MIDI Mono, goes over to the AD5DZ CW keyer and keys it. So we're converting audio to MIDI and then MIDI back to audio. That's the general concept. So we have DAWs. Again, as long as you hold that blue wave down, it keeps sending that 555 voltage into the mic jack, where Trigger MIDI Mono is picking it up and sending a continuous MIDI note 1 out. So the attack time is the threshold level that you set. The other are just default set here for this video. The RMS mode was important. We want to take an average of the 555. The reactivity is how quickly it responds to a change in the voltage. And the time here is how long it will hold the green wave after the blue wave stops. You can adjust the time here, control, to adjust for any problems you might have in keyer bounce. So the mechanical bounce of the keyer sometimes will cause erratic notes. So you can turn this up a few milliseconds and put a stop to that. And if you have to turn it up more than that, in the AD5DZ keyer, you can turn the length of the DIT and DAW down by compensation, by trimming off a millisecond or two, or however many you need, so that it will return the note to exactly what you want to hear it at. So for DITs, we're sending MIDI note 0. The incoming blue wave, once it goes over that pink-purple wave, creates a green wave that tells AD5DZ CW keyer to send DITs. It's an iambic keyer application. Same thing for the DAWs, and of course the DIT DAW iambics, when they're both activated at the same time. So that's the overview of basically how it's working. Let's go into the software a little bit. And again, I'll give you an overview first of it. This is Trigger MIDI Mono, and the actual application that creates the keying is this here, the Rec keyer. That's what he calls it. AD5DZ is the author. So here you can adjust the frequency. I'll demonstrate some of these. You have, first of all, you have A or B mode. I'm using B mode as far as iambics. So this keyer is taking the DITs and the DAWs from here, and it has two inputs. And based on those inputs, it creates keying instructions for this keyer here, just like a normal keyer would. And you have all sorts of things you can adjust on here. How fast you want the keyer, so let's do that. And so forth. And you can adjust timing, weight, the dit-da ratio. The compensation is what I was talking about before. If you have to increase trigger MIDI mono's release time to compensate for key bounce, you can trim off or make it heavier by the same amount for dit and da. So we'll take this back to 0. Here's the frequency, so we'll turn it up, turn it down. And the gain, you can make it louder or softer, turn it down, turn it up just a little bit here. Okay. And we'll keep it right at 6 here. And you have the rise and fall. You can adjust those separately, or use the ramp to adjust them all at the same time, both at the same time evenly. So right now the ramp's at 9, so it's really a 9 millisecond rise and fall time. As long as these two are even, it doesn't matter. As long as they're even, the ramp will adjust them by the same. So we'll take this keying down to, say, 3. It should sound harder. So you hear that little knocking. And we'll take it up all the way to 15. Makes it soft. So I'll leave it about 9 for now. You have raised cosine windows. I'm using the cosine on top of, or multiplied by the Gaussian window. And that changes subtly how it sounds. So this is a very versatile CW keyer. With just about anything you can adjust, it has an option for it. So let's show you how it's connected inside the software. So right here is the mic jack called System. We have the left channel, which the dits are coming in, and the right channel where the DAs are coming in. So the DA channel is connected to the DA trigger MIDI mono. The DIT channel is connected to the DIT trigger MIDI mono. Out comes MIDI note 0 for the DITs coming into this 85DZ key app, which is combined with the actual iambic keyer app right here. These two work together. This takes the input 0s and 1s and turns it into one output, which keys the CW keyer, and out comes the audio here. And the DA sends out MIDI note 1. So between the 0 DIT and the 1 are both at the same time. This part of the application of the AD5DZ iambic CW keyer, software CW keyer, channels that out the MIDI output. The MIDI input of the keyer knows what to do and perfectly represents what you were originally trying to do in real time. So the latency is so low you won't notice it. If you have your settings here, I have a buffer size of 128 at 3 periods, and it's about 8 milliseconds, I think. So anything less than 25 is called near zero real time in the music industry, and you really shouldn't notice much as far as performing the art of CW keying with your iambic paddles. So that's that setup as far as the internal software goes. Now I'm going to go back and we're going to show you more of the 555 and what it sounds like and acts like when we key it, before all on the outside as it goes to the computer mic jack. So I'm going to change a few things here so that you can hear it. So we're going to take the keyer out of the picture for now, and we're going to turn up the tone of the ambient 555. You should be able to hear a little bit now. And I'm going to show you what that looks like. So basically, this is taking the energy through this little amplifier here, coming out of the mic, or coming into the mic jack from the 555, coming out of the 555. There's a little leakage that comes through, but it's not a big deal because trigger MIDI mono's threshold is above that ambient level. So we have it coming in here to this amplifier, going through a AGC right here with this application, going to the headphones so I can hear it, and going to the screen recorder so you can hear it. Now we'll go to the scope view. There we go. And so this is what the wave looks like. I'm going to press down the left paddle, and this energy is going to increase over 20 dB. Same thing for the DA, the red wave. That's the DA paddle. So that's what's coming into the mic jack. And this is the energy that trigger MIDI mono is using once it goes above that level. Again, see how high that blue wave comes above its level, of its normal level. Same thing on the dits up here. And all it has to do is just be under that purple wave so that it doesn't activate or send anything. It just has to be above it. So this is way more than enough that is needed to get the job done. And you see these sharp curves between the blue and the green. That's so you get a clean make and break. And you can see the timing is right on top of each other. So the latency is just a millisecond or two at the most. So the reason you see a downward wave and not an upward wave is we have those two germanium diodes in an energy harvesting setup. That's what's powering the TLC 555, which is a low power version, and it runs perfectly at 2 volts. And I have 2.1 volts measured here at pin 8 with this setup. So we have these 2 germanium diodes here, which you can see on the picture to the right as my mouse cursor's surrounding them in a circle, so that they're connecting to the voltage that's present at just about any sound card microphone jack, because that power is needed to power the electret microphones that most headsets have. And at the microphone port here, it's about 2.9 volts. So there's only less than a volt drop before it, as it reaches the TLC 555 going through the diodes, and with the TLC 555 running all the time. Let me turn down this tone here. Okay, so we have a diode to the right, since this is a stereo mic jack, and you need a stereo mic jack for this to work because we have to send dits on one channel and DAWs on the other, as far as the tone that activates that software CW keyer to do its job. So this energy harvesting circuit is charging up a 0.47 microfarad capacitor to power pin 8, the 555. And again, measured here, it's 2.1 volts, and this voltage doesn't change even when you key it. It stays at 2.1, so there's no big voltage drop when you key it, because this is all pretty high resistance through here. We have a load on pin 3, which is the output of the 555, of 10K to ground. The timing capacitor is 0.01 microfarads from pin 2 to ground. And in this setup, there's a ton of different setups for 555 oscillators, and the ones that are on all the time. So I have a 47K from pin 3 to 6, 47K from pin 6 to 7, and with all this combination, it creates about a 2 kilohertz oscillator with 2.1 volts at pin 8. Now, as far as the storage capacitor, you don't want this to be too much, because then you get on those trigger MIDI mono apps, you don't want a high release. You see that there's a slight at the very bottom, there's a slight expansion. In other words, it doesn't quite go all the way sharp all the way down. But in this particular version, you just need it to be sharp enough to do the job. And so 0.47 was just enough to activate the TLC 555 to do its job, but not too much where you get this curve is too long of a curve. So that will make the DIT or the dial longer than it should be. But as you can see here, it's doing just fine with the current levels. And you can probably experiment further with this and get it even sharper. But that's the reason we chose that storage capacitor for this energy harvesting part of the circuit. We chose germanium diodes so that it doesn't kill the voltage with a too high of a voltage drop over the diode itself, so that we can get as much to the TLC 555 as possible without super draining the mic jack power, which this really can't power a lot of current, but it's plenty and it's more than enough to do the job that it's doing using this low power 555 here. On the paddle side, we're connecting the ground of the paddles to make this work to a 0.002 microfarad capacitor, which is connected to pin 3, the output pin of the 555. So when you smack that right or left paddle or both paddles to their contacts, it contacts ground. So then the path goes from the 3, output of the 3, through the right or left channels or both, and makes its way over to the right or the left input for the mic jack. The mic jack ground and the TLC 555 ground are connected together so that this works properly and powers it up, but we don't ground the paddles. Paddle ground is directly isolated but connected to the 0.002 microfarad capacitor, as you see here. And I think that's just about it, except for maybe the wire connection between pin 4 and 8, which is a typical one you see, so that it's on. This turns the TLC 555 on. Now, some of these 555 CW keyers, you actually toggle on and off this wire between 4 and 8, and that's what turns on and off the 555. But we want this 555 on all the time. And we want it to be stable so that when you do send energy out pin 3 and it connects with the mic jack, you don't want a big voltage drop at all on pin 8, so that it makes the waveform wobbly. So that's more of the details of the circuit. Over here you see the germanium diodes. We have the 0.47 microfarad capacitor right here. This side of the breadboard is ground with the black wire. This black wire is connecting from pin 1 over to the microphone jack ground. Now I have a cable over here at the laptop where the mouse is circling. That's the mic jack coming in, stereo mic jack, and it has left and right sides coming out. And the wires are stripped down from their insulation, so it exposes the left hot lead and the right hot lead and the two ground shields, which are connected together and are connected to this clip lead here. So that's how this cable here, ground, is connected to the TLC 555 ground. This is the 0.01 timing capacitor. This blue cap is the 0.002 microfarad capacitor. And that's what's going to, makes its way over to this paddle ground. I'm not showing the clip leads for this, but they're represented here on this schematic fairly easily. So that's pretty much it for that. So let's take a look at the spectrum. And right now this is the energy level at minus 53 of the ambient CW. So let me go turn the CW back on now. So we're going to send this to the sound card. This is the output of the keyer. And we'll send it over here to the recorder so you can hear it. Okay. So it goes up to minus 30 from minus 53. So that's over a 20 dB boost. So we have the left side here, the dits. And now the DA. And here's the spectrum. So we have a main at 2 and a double at 4 there. However, there are some harmonics generated with the type of waveform that's coming out of the 555. Of course, you're going to get harmonics with just about any 555, and that's fine. That helps stabilize the trigger MIDI mono apps. So just to review here a little bit, all these apps are connected to the microphone jack, which is right here represented by system. The other system is the headphones that I'm using. And this is a screen recorder. These are the apps I'm using to speak through a webcam mic so that you can hear my voice. So again, we have the dits and DAs coming into trigger MIDI mono. It goes to the 85 DZ keying app. When you bring up the CW, the iambic CW keyer 85 DZ, it brings up both of these. And this outputs MIDI data that clones exactly the incoming data, the audio data. So it's an audio to MIDI conversion app. This takes the MIDI data from the dits and the DAs, which are zeros, MIDI data 0, MIDI note 0, and MIDI note 1, converts it to typical iambic keying, which comes out of here, and this is just a typical tone keyer, a MIDI CW keyer. So this keys the software CW keyer, which we went over already, the Recre keyer. And more information and links will be in the video notes. So I think that's just about the basic framework here of how to get a 555 connected to your paddles to key CW on a Linux or Raspberry Pi computer. Thanks for watching.